Hello everyone, welcome back to the channel. In this video, we will talk about multi-agent systems in LangGraph. But before we move on to the topic, I'll just try to reflect back on this playlist here. So I've created this playlist on LangGraph and I'm explaining all the aspects of LangGraph in this playlist in detail, along with the conceptual or theoretical uh, knowledge. I'm also providing the project, a sample project for each and every concept, whatever we are discussing here, right? So we started with LangGraph introduction, and then we moved on to LangGraph state graph concept. Then we also saw React agent using LangGraph, how to create a React agent using LangGraph. Then in the last video we saw model context protocol (MCP), right? And then we use LangGraph here to implement this model context protocol. In this video, we will be talking about multi-agent systems, okay, and we will learn about multi-agent systems with some real life analogies, real life examples, and we'll also see a sample code or a sample project, as we have already seen in other videos also. So now let's get started with multi-agent systems. So let me just choose a marker here. Okay, so now to start off with, what is or what are multi-agent systems? So let's understand this from a real life analogy. So let's imagine that you are organizing your college fest. Okay. So you can't do it alone. So we need to form a team, right? So team is an important word here. So in the team, every person will have different responsibilities. For example, one person handles sponsorships, another takes care of decorations, another person manages social media, and there is a coordinator, right, who keeps everyone on track, right? So each person is a specialist, and together they make the fest a success. So this is a teamwork, right? So this is how exactly the multi-agent systems work. Okay. So in multi-agent systems, multiple AI agents, each with a specific skill or specific expertise, work together to solve a bigger problem. So now let's see what are the types of multi-agent architectures here. Okay, and we'll see or we'll understand these with analogies, real life analogies. Okay, so now we have a few types of multi-agent architectures here. So the first one is network, right? This is the first one. So in this one, all team members can talk to each other freely. Okay, so everyone has equal importance in in this type of architecture. For example, like a college WhatsApp group where anyone can ask or reply any questions or comments, right? The second one is supervisor. In supervisor architecture, one person controls, who does what. So he's like a supervisor. For example, he can be a fest coordinator, right? So everyone reports to the coordinator. So now we have the third one, which is supervisor with tool calling. Here, the supervisor uses a language model that sees other agents as tools. So there are multiple agents, and these agents are like tools here. So they work like tools here. So it chooses which tool or agent to use, right? So it chooses which tool or agent to use. The fourth one is hierarchical. So this is the fourth one. So here there is a main coordinator and there are multiple sub coordinators, right? So there's a main coordinator and then sub coordinators. So like a team lead managing other sub teams, correct? And then we have the fifth one, which is a custom workflow. So here we can create our own rules, right? There's no fixed set of rules here. We can decide how the flow should be, right? So maybe we can say that maybe sponsorship talks only to finance agent, right? And the decoration agent talks only to design agent, correct? So here we create our own workflow. So we set the rules, okay? And now let's see the uh, diagrammatic view or pictorial view of this concept. So I've taken this from the official documentation. So here, so we have 6 types of architectures here. The first one is the single agent. This is a simple one, right, where the LLM is there, and this entire thing is like an agent. All the green boxes here are like agents. Okay, so in a single agent, which we have already seen in previous videos, there will be an LLM, there will be multiple tools from where So this LLM can basically use this multiple tool to generate the answer or to get the responses. So this we have already seen in multiple videos in this playlist, right? So the next one is the network. So here we have multiple agents, right? One, two. So there are four agents here, and all of these are communicating, right? Equally, they are communicating equally with each other. Everyone, all of these agents have equal rights or equal importance here in network type. Third one is supervisor, right? This is the third one. So here we have a we have a coordinator agent here, which kind of assigns the tasks to the other agents. The fourth one we have is supervisor, but as tools, right? So here is the we have a LLM, and then all these agents work as tools here, right? So these are agents. All the green boxes are agents. So all these agents work as tools here. So now next one we have hierarchical, right? So here we have the supervisor, then we have sub supervisors, right? In every division here. So this is hierarchical. And then we have the last one is custom flow. So custom flow, basically we decide our own workflow, we decide our own rules, how we want the workflow to look like, right? So here we have multiple or different agents here connected in a random way, we can say, right? Which has been decided by the developer, like in what should be the workflow, right? So these are the six types of multi-agent architectures, which we will be exploring one by one, using LangGraph here, right? So now let's see another real world example here. So this is the example which we will be working on, right? This is a sample project which we'll be creating in this video later, right? So here, this is a real world example. So let's say we build two agents, right? We build two agents. The first agent is a finance advisor, suggests how to invest money, right? And then the second one is a tax advisor. This basically tells you how to save tax. So we have two agents here. Both of these are agents. So these two agents can talk to each other. This is exactly the network type of architecture, right? So we are basically looking at a network architecture, right? Right? So this is a network architecture where both of these agents can talk to each other, both have equal importance, and based on the communication, basically this entire system architecture decides which agent can be used to answer a particular query, and this is all done automatically. Okay, so if for example, if the finance agent is confused about tax rules, it asks the tax advisor or the tax agent, right? Similarly, if tax agent wants to confirm investment plans, it asks finance agent. So this is a network architecture, right? This is a network architecture. So here there is no boss, it is just pure teamwork. Everyone has equal importance, or both the agents has equal importance. Both the agent gets to decide which agent is going to answer based on the query, the user query. So let's see this flow diagram here. So first of all, we have this first agent, which is the finance advisor, and then we have the second node, which is the tax advisor. And again, these both of these communicate with each other. Let's say the user asks a question about finance, so it goes to finance advisor. So if it is able to answer on its own, it directly responds back here, right? It directly responds back here. But let's say if the user asks a question about tax saving, so here at this point, this finance advisor agent will not be able to help. So it transfers this question to the tax advisor agent, right? And then it basically uh, gives the answer or response for that. But again, let's say if tax advisor also doesn't feel like this is not related to tax, then it can again transfer back or communicate back the response to the finance advisor, and this communication goes on until we get the correct answer, and then finally the final response is returned. So this is the entire flow here, right? This is the flow diagram which we will be creating in the coding section. So and so what is the cool part here, right? So here we are not using any API keys. You don't need any internet or any API keys for the model, right? We are using Ollama, which runs locally in the laptop. So we'll be using Llama 3.2, right? We'll be using Llama 3.2 to generate the responses. So this will be our model, correct? So this was all for the theoretical part. Now let's move on to the coding section quickly. Okay. So here I've written the code, for this particular workflow. So first of all, we start off with importing the necessary modules here. So first of all, we import chat Ollama from LangChain Ollama. Then we import the tool from LangChain Core Tools. Then we import message state graph, and start from LangGraph.graph. And then we also import the other required modules. Then we basically call the model here, right? So we are using Llama 3.2. Then we create a couple of tools here. So these tools will not be doing any functionality, but these are just for transferring the flow from one agent to another agent, right? So this ask tax advisor tool basically. So we are saying that use this tool to transfer the question to the tax advisor if investment advice needs a tax clarification, right? So we'll be using this tool to transfer the question to the tax advisor. Similarly, we have another tool which is the Ask Finance Advisor. So we'll be using this tool to transfer the question to finance advisor if tax advisor needs investment insight. Correct. So these tools will not be having any functionality, but this will only be used to transfer the flow between the two agents. Right. So now we'll create our first agent, which is the finance agent. Right. This is the first node. Right. So first of all, we use this message state to basically communicate or pass on the variable values throughout the different nodes in this workflow, right? And then we give the system prompt. So system prompt for this finance advisor is: you are a finance advisor, recommend investment strategies, right? If tax concerns arise, use the ask tax advisor tool. So we are saying that if there's a tax related query, then pass on this query to the tax advisor agent, right? Then basically we create the prompt here, and then we bind the tools with this model, this particular model. So we have already seen how, what do we mean by binding the tools in this playlist, and then we pass on this particular prompt here inside the invoke function, right? So now we are saying that if there is a tool call, so there will be a tool ID, right? And then we are saying tool message, where we are basically putting all these tool messages in this particular dictionary. So the role is tools, content is successfully transferred, and we are also recording the tool call ID, right? And then we are saying return command go to tax advisor, and then we are updating the message with AI message and tool message, right? So this will be having the response. So we are doing the handover here. If the question is related to this tax related question is there, then we are doing a handover to the tax advisor agent. Now we'll be creating the tax advisor agent. Here again we'll be using the message state, and then we are saying you are a tax advisor, provide tax advice. If investment guidance is needed, use the ask finance advisor tool. And then we are creating the prompt here. Again we are binding the tools, and we are passing the prompt in the invoke function. So again we are saying if there's a tool call, where we are basically filtering out all these variables like role, content, and tool call ID, right? So role, we are just saying it is a tool. Content, we are just hard coding it to successfully transferred. And then tool call ID, basically we are getting it getting it as a tool call ID in this particular variable, right? From here, this we are recording this tool call ID from this particular variable. From we are getting this from AI message, right? So if there is a tool call, there will be a tool call ID, to summarize this. Then again, we are saying return command, go to finance advisor, and then we are updating the message state, right? Where we will be having the response as the AI message and the tool message, correct? And then we are returning the message, which is the AI message from this particular agent. Now we will be creating the graph. This graph is basically a state graph where we are passing on the message state, and then we are adding the nodes. The first node is finance advisor, the second node is tax advisor, and then we are adding the edge between start and finance advisor here, right? And the remaining edges are already added using this command, this command literal here, right? So we are already adding this remaining edges. If you see, tax advisor to end, finance advisor to end, correct? So these we are adding here only while creating the agent or the node here, right? So this is another way of adding edges basically, right? So we can do the same thing via this add edge functionality or method also. And then we are compiling this graph, and we are putting this in a app, this particular app variable. Then here we can plot this workflow using this particular snippet. So we can see the same snippet. There's a start node, then we have a finance advisor node. So if when the user asks the query, if the finance advisor is able to take that query and answer get the response, then it sends the response straight away. But if the finance advisor finds that this query is related to tax, then it sends it to the tax agent, and then tax agent gets the response and give the final response. If not, then it again can communicate back to the finance advisor that this is related to some finance related query, right? Okay, so this is the flow. Basically this is the network architecture. So next, now let's keep on running the snippets also. Okay, so first of all we'll run this a second. So tax agent, we'll compile it, then we are going to draw the flow diagram here. So it might take a few seconds. Okay, so now we let us just run this particular part. Now let's see, we are asking the question, right? We are saying suggest how to invest money. This is a generic question, right? So the purpose is to just see the flow, how how the communication happens between these two different agents, right? So now let's run this. So let's wait. It might take a few seconds. So it is saying successfully transferred. So it basically starts from finance advisor, right? So this question is ideally for the finance advisor. So now then it tried to transfer it to tax advisor, but then again it got transferred to the finance advisor, right? So there's some communication happening over there. Let's wait for a few more seconds. Okay. So here is the answer. The final answer is coming from the finance advisor node or finance advisor agent. So it returns a generic response here, like based on the input parameters. So it's a personalized investment strategy, and then it gives a lot of details over here, right? So now let's ask another question related to tax. This is suggest how to save tax. So now let's run this. So it starts from finance advisor. Okay, update from node finance advisor. So now it says successfully transferred. So let's see how the transfer happens actually. Okay, okay, let's run this again to just get a proper format of the response. Okay, let's wait for a few seconds. Okay, it might take a few more seconds here. Okay, we again got the result in the same format. Okay, but now the thing to note here is that first of all it starts from finance advisor, and then it transfers the query to the tax advisor because it's a tax related question, and then it gives the response here, right? So we have the response, tax advantage of tax deferred savings options through your employer or individual retirement and so on, right? So the point to note here is how the communication happens. So it started from the finance advisor, then it saw that this question is about tax saving, so it transferred the flow or query to the tax advisor agent over here, and then this tax advisor agent gives the response to the user, right? So this was the entire flow for this network architecture, right? So guys, you can try with different models. Maybe sometimes some other models might do better than this, right? And you can also try with some different prompts. This is just a sample project which I provided, and you can always tweak this code as per your need, as per your requirement, right? So if you want to just play with this code, so I've already put this code inside this Git repository. So the file name is network multiagent.ipynb. I'll be putting this URL in the comment section of this video, right? So feel free to use this code, change this code as per your need, and build some. You can build some projects. To first of all to learn this concept, or even if you need to use this code for some use case, feel free to use it, right, as per your requirement. So this is all for this video. um, I'll be back with another video with the next type of multi-agent architecture. If you like the content, subscribe the channel, guys, and like the video and share the video with your friends so that maximum people can benefit from this. See you in the next video. Till then, thank you.